Welcome to Calculus. Today we will investigate how to find volumes of revolution about shifted axes, and we'll be using the disk method. Let's take a look at two examples. Our first example is this function y equals the square root of x plus 2, and we're interested in the revolution that is created by the solid enclosed by that function and the line y equals 2 and x equals 1, and we're going to revolve this portion of the function around the axis y equals 2. So let's situate that function and the axis here on this graph. So I want to graph this function square root of x plus 2. So at 0, square root of 0 is 0 plus 2 is 2. So we've got our starting point for the square root curve there at 0, 2. At 1, the square root of 1 is 1 plus 2 is 3. And then the next convenient x value for me to take square root of would be 4. So square root of 4 is 2. 2 plus 2 is 4. So at 4, we are at the y value of 4. And that allows us to sketch that square root curve. So it's been translated up to from the parent function. We're going to consider that it's between that curve and this line y equals 2 that we want to capture our region that we're going to revolve. And then we're also going to consider that it's between those two curves and also x equals 1. So it's a very small, relatively small region that we're going to revolve. And we're going to revolve it not about the x-axis or the y-axis, but the line y equals 2. So it's been a shifted axis, it's been shifted up to. So what we got to decide is how that's going to be set up as an integral. So just in general terms, for a shifted axis, and we'll consider first functions defined in terms of x, it's going to be pi times the integration from a to b. I was going to say ours is from 0 to 1, but we'll fill in specifically in a second, times the function f of x. And if I were rotating or revolving about the x-axis, I would just square that. But it's a little bit different here. I want to say that the radius is going to be defined by f of x minus my other axis. We'll call it g of x. And then we're going to square that dx. So I just have to take into account the main difference here between revolving about x-axis or y-axis is this subtraction. Well, let's set that up for our specific example here. So our volume is going to equal pi times the integration from 0 to 1 in x times f of x, which is my square root of x plus 2, minus, so I want to subtract by really the axis that I've shifted. So that function, I'm treating it as g of x is minus 2. And then I'm going to square that dx. So there's our setup. Once I've set it up, I just need to reduce, simplify, and then integrate. So for reduction here, it's going to be pi times the integral from 0 to 1. Now, if I combine these two functions, square root of x plus 2 minus 2, really all that's going to happen there is my 2's are going to cancel. So I'm just left with the square root of x squared dx. And that's going to really simplify down to pi times the integration from 0 to 1 of x dx. So now we're ready to integrate. The pi will stay. Integration of x is 1/2 x squared. And then we're going to evaluate from 0 to 1. So now we want to make those substitutions and evaluate according to fundamental theorem of calculus. So that's going to look like pi times 1/2 times 1 substituted for x squared minus 1/2 times 0 squared. So the second term there is going to just zero out. So I'm just really looking at 1/2 times 1 squared, which is 1/2. And that's going to give me my final answer here of pi over 2. And that has the approximate value of 1.571. cubic units. So I'll go ahead and put that unit there to indicate we have solved for volume. So our first example there is revolved about this shifted axis y equals 2. So definitely that one's a function defined in terms of x. Let's take a look at an example of a relation defined in terms of y. So our relation here is x equals negative y squared plus 2. And we want to consider that it's been shifted over our axis, which is usually the y-axis, has been shifted over into quadrants 2 and 3 to this line x equals negative 2. So I'm going to just draw that line in to begin. So that'll be the axis of revolution. So I'll go ahead and just draw that. We're going to revolve around there. And then I want to graph this relation. So I'm just going to choose some y values and then evaluate to solve for x. So the first y value I want to choose is y equals 0. So 0 squared is 0, negative 0 plus 2 is 2. So then let me consider these positive y values. So positive 1, 1 squared is 1, negative 1 plus 2 is 1. And then let's consider y is 2. So 2 squared is going to be 4, negative 4 plus 2 is negative 2. And that's where that relation is going to intersect the shifted axis there on the left. Let's also consider negative values for y. So negative 1 squared is positive 1, negative 1 plus 2 is 1. So I see a symmetry here. It's definitely a quadratic or a parabola that's been turned on its side. Let's also consider y equals negative 2. So negative 2 squared is 4. Negative 4 plus 2 is also negative 2. So that fills in the picture. And that's what I'm trying to find, the volume of the solid revolved. So that's the kind of the profile that we're going to turn around that line x equals negative 2. So our volume in this case is going to be defined as pi times the integration on my y. I was going to say y-axis, but it's really the shifted axis x equals negative 2. So it's from negative 2 to positive 2. And then for my function, which again is going to determine the radius of the revolution, in this case, it's going to be, instead of the upper function minus the lower function, it's the right relation minus the left relation. So that's going to be negative y squared plus 2, that's the right relation, minus the left relation, which is that shifted axis negative 2. We'll square all that and integrate with respect to y. So now once we've got it set up, our task is to simplify our integrand. So this is going to become pi times the integration from negative 2 to 2 in y. And I see here that basically I'm going to have a negative times a negative. So that's going to become positive 2. When I add that to the 2, I'm going to get negative y squared plus 4 squared dy. And then I can further simplify the integrand by distributing, by FOILing. And that's going to give me this new integrand of y to the 4th minus 8y squared plus 16 dy. So we just kind of speed through that double distribution of negative y squared plus 4 times itself. That's ready at this point to integrate. So that's going to be equal to pi times 1/5 y to the power of 5 minus 8 over 3 y cubed plus 16y. And we're going to evaluate this from negative 2 to 2. So at this point, if you've watched the previous lessons, you'll recognize this exact integration. The only difference is we've seen it turned in different directions, but regardless of the turning, if it's the same profile and we're revolving it around the axis, we're going to see the same volume. But let's calculate again just to practice that evaluation skill. So I'm going to substitute in 2 first. That's going to give me basically 2 to the power of 5 is 32. So 32 over 5 minus plugging in 2 to y cubed is going to give me 8 times 8/3 is 64 over 3. And then 16 times 2 is 32. When I substitute in -2, everything's going to be the same, but because these powers are odd, I'm going to preserve the negative sign. So all the values will be identical, but the signs are opposite. So -32 over 5 plus 64 over 3 minus 32. So then what I'm noticing, because those are really similar values left and right, they're either going to cancel or double. I just need to check with the sign. So if I distribute this negative sign through, it's going to flip my signs and it's going to match exactly what I got in that first group. So it won't cancel, it'll double. So I'm going to write 2 pi times 32 over 5 minus 64 over 3 plus 32. At that point, I need to get those 3 values added up. And to do so, I need a common denominator. And it looks like that's going to be LCD of 15. So 32, I need to multiply by 3. That's going to give me 96 over 15. When I multiply 64 by 5, since it's got denominator 3, it's going to give me 320 over 15. And then 32, I got to multiply by 15 itself. And that's going to give me 480. So then I can add up the numerators. And that's going to give me 2 pi times 256 over 15. And then multiplying the 2 through is going to give me 512 over 15 pi. That's my final answer. Exact approximate versions about 107.233 cubic units. And we'll box both the exact answer and the approximate decimal. Thank you for joining for these 2 examples of calculating the area of calculating the volumes of solids created by revolving about shifted axes. We took a look at horizontal shifted axes as well as vertical shifted axes. See you soon.